Hey guys, welcome back to the channel. Today I'll show you how I built a smart search functionality for my website using ChromaDB and vector embeddings. At first, I'm going to quickly show you a demo of the feature. Then we're going to dive into the system design. And finally, we're also going to take a look at the code that powers the whole thing in production. So starting with the demo, we have a search box here. Let's try to search something. I'm going to search for, let's do Savannah, Georgia. Okay, so you see the second blog post over here. And perfect, you see the four blog posts that could be related to Savannah. Now, if I search for, let's do, I don't know, system design, and then search for it, you're going to see I'm getting all the YouTube videos that are related to system design. And finally, let's try another one. I don't know, let's do like maybe personal finance. You're going to see all the blog posts that could be related to personal finance. We're going to do one more, maybe let's do like Kafka streaming. And you're seeing all the YouTube videos related to Kafka that I have posted in the past 3 to 4 years. So that's how this works in production. You can go to the website and check it out. But now I'm going to move to the system design. So the system design is divided into two big segments. The first one is whenever a blog post is created or a YouTube video is posted, how do I generate embeddings and store them in ChromaDB? The second part is going to be the read time. So when someone puts a query, what are the backend endpoints and backend systems responsible to give back the list of results that you see, right? So every time I have a query here, let's say gas credit cards, the backend is actually working, reading from ChromaDB using OpenAI to get me the most relevant 5 or 6 blog posts in this case. All right, so let's start with the first one, which is going to be the writing part or storing part. So I have all my blogs stored in a local directory. So if I show you my directory here, you're going to see all the files are in the directory. It's in the front end code. The second part is the YouTube API, where I'm constantly pulling YouTube API to get the latest content on my channel. So whenever a video is uploaded, the API almost immediately captures that. And for the blog, it's going to be whenever I upload the markdown file, I kick off this process to generate the embedding. Now, we have both types of content, the file systems or blogs and YouTube videos through the API available. There is an endpoint that I run. I'm going to quickly show you that over here, create embedding. And this is the endpoint that gets called every time a new piece of content is published. It's very simple. The endpoint takes in 2 parameters, YouTube and blog post. Depending on which one you set or both of them, I create the embeddings or the vector embeddings for either my YouTube videos or the blog posts. So this is the embedding part. Now, how do I generate the embedding? I'm going to show you the code, but in sort of very short terms here, the embeddings are generated through OpenAI. So OpenAI gives you a function that you can call with your piece of content, and it's going to automatically create the embedding for you. You can also use locally running models, but I run my code in a very tiny server. So using a locally hosted embedding model was getting a little too time consuming and resource intensive. So we're going to use OpenAI in this case. Every time a piece of content is uploaded, I go through the same process. We get the content, we call OpenAI function to create embedding, and then we store both the embedding and the content in a locally hosted ChromaDB database. Why ChromaDB and not like Postgres or something? I used to use Postgres before because Postgres also gives you a way to store vector embedding, but ChromaDB in the last couple of months have come quite far, and it's super easy to set up a local instance. And you're going to see that right here, where everything I have is stored in this local ChromaDB, which behind the scene is a SQLite database. That's all. I do have a little bit here I can share as well. So this is the local table, and you're going to see all the tables you see here, or collections. I think that's what ChromaDB calls it. All these tables are automatically generated by ChromaDB. So if you look at maybe one example, you're going to see like all my contents here, all the embeddings are over here. So everything is locally hosted, which makes it very, very straightforward. I don't need to maintain another instance for my database. The other cool thing that ChromaDB gives me is going to be in the write phase, which I'll get to very shortly. So just to summarize the write process, every time a piece of content is published, whether it's a blog post or a YouTube video, process gets kicked off where the system calls an API endpoint. The API endpoint is responsible for generating the embeddings through OpenAI or using OpenAI, and then storing both the content and the embedding in a ChromaDB database. I will show you the code of how the embedding creation process works, but before that, let me go through this at a high level, the read pattern or the read path, and then we'll jump into the code. Now, at this point, we should have embeddings being created every time a piece of content is published. Now, let's look at the second part, which is the read part. So again, whenever I do any query here, let's say wallet setup and search, to get the result you see over here, the client needs to hit a backend endpoint called get user top recommendation, which takes in a query parameter. In our case, this is going to be whatever you type here. Now, with that data, what the system is going to do is, here's the query, the endpoint. Let me just zoom in a little bit more. Okay, here's the query. The endpoint passes the query to the backend server. Now, in the backend server, this is where you're going to see another power of ChromaDB. The first thing the server does is takes the query and generates an embedding for that query using OpenAI. Now, once that's done, we have the query and we have the corresponding embedding or vectors, which is just a list of numbers. Okay. After that, ChromaDB gives us a function you can use. Most databases that support vectors has the function, but ChromaDB's one is very straightforward to use, and I'm going to show that to you in a little bit. So we have the query, we have the embedding, and then we use that ChromaDB function and ask ChromaDB, hey, here's my query, here's the embedding, go look at all the embeddings for all the content that you have in the database and give me the top 5 most relevant content for this query, whether it's a blog post or a YouTube video. Okay. And in response of the query, ChromaDB gives you a list. You can give it the count, like do you want top 3, top 5, and you can also give it a threshold. Like when ChromaDB tells you how similar a document is to your query, it gives you a number. So if the number is very low, that means the match is very low as well. So you can create a cutoff where you tell ChromaDB, hey, give me the top 5 pieces of content or top 5 most relevant pieces of content, but don't give me any if the similarity is less than 0.5. Okay. So these are the 2 paths. One is going to be every new piece of content gets its embeddings created using OpenAI, and then the data is stored in ChromaDB. And then at read time, whenever there is a query, the server generates embedding for that query and then uses a ChromaDB function to find the most similar or most relevant content based on that query. Now, maybe let's take a look into the code to clear things up a little bit more Similar to the design, I'm going to break the deep dive into two parts. We're going to look at the generation part, and then we're going to look at the read part. Okay, so looking at the generation part, the code is going to be linked in the description below. So feel free to check it out yourself, but we're going to go through this together right now. So for the creation path, whenever a piece of content gets uploaded, we call this function, or we call this endpoint called create embedding, which creates embedding separately for YouTube or blog. We're going to look at blog at first because that's a lot more straightforward. So this is the function that creates it, and you're going to see we go through the file name. So we go through all the files, all the blogs in the local directory. We parse out the markdown content from the file, and then we do a check to see if any of the file is already stored in my database. So any blog post that has already embeddings created, we want to skip that. And that is because we are using OpenAI to generate our embedding, so we don't want to unnecessarily pay money if we already have the embeddings. So we do that check. After that, it's a new blog post. So we parse out the title, description, and then a bunch of the content itself. After that, all we're doing is using this .add function. Okay, the add function is going to be coming from content collection. Now, what is content collection? Let's go up. You're going to see it is a pointer to the ChromaDB client. Okay, so we're instantiating ChromaDB client. We're getting the collection. Collection is sort of like a table. And then we are using it over here. When adding the piece of content, we're giving it the markdown content. So this is the full blog post. And then a bunch of metadata like the title, blog URL, whether it's a YouTube video or a blog post, things like that. Now, one key thing you might ask is, where are the embeddings being generated? And that's going to be over here. Whenever I am instantiating the ChromaDB client, I'm giving it the name of the table or the collection, and I'm also giving it an embedding function. Okay, and the embedding function in this case is an OpenAI embedding function that is being created here. When generating the embedding through OpenAI, you can also pass it a model, and I think you can find more about it in the documentation. Just like I'm using an OpenAI embedding function here, you can use one from Claude, you can use one from Gemini, or you can host one yourself and then just point towards that here. Very simple. You don't have to actually write the function to generate the embedding. You just pass it to your ChromaDB client. This was one difference with using Postgres, because in Postgres, you have to write a few more lines of code to generate embeddings. Whereas in ChromaDB, everything just works as long as you pass in the function. So yeah, that's how the blog embeddings are generated and stored. And now going back to the endpoint, we're going to look at the YouTube embedding. So for the YouTube embedding, it does something very similar. The first part is different because here we're polling our YouTube API to get all the results. We're doing the check again, like last time, to make sure the video does not already, it is already not in our database. If it is not in the database, then we go ahead and do the exact same thing where we embed the content, generate the vector embeddings, and then store it in the database. Okay, so that's the read part, that's the write part done. So this part is done. Now let's look at the read one. As a quick reminder, for the read, everything starts with the search box here. If you search for like semi-SQL optimizations, you see everything over here, and you're going to see all these are relevant to SQL or databases. Now let's look at the code. Everything starts with the endpoint recommendation, which takes in a query parameter, which is going to be whatever the user types in the search box. Now when we go to the function, this is very straightforward. All it does is it uses this .query method, passes it the query string, so the user's query, and end result, so the number of results to return. this gets ChromaDB working. It does all those vector math to figure out the 5 most relevant content, and then it gives those back to us. I'm parsing the response to break apart the documents. So these are the actual documents, the metadata, and then distances is the metrics that ChromaDB uses to understand how similar the documents are to the user query. And then I'm just going ahead, parsing through the response, doing some manipulation here to make sure everything is formatted correctly. And I'm also passing in the score, okay? And then returning the recommendation. So that's all you need once the data is already there in ChromaDB. Now, you might ask, where is this step? Where is this step, right? Where I'm supposed to be creating the embedding for my query. So that automatically happens here. Whenever you're invoking the query method, passing in the string or the query text, ChromaDB already knows that as the first step, it has to generate embedding for that query text before it can actually do the math to figure out. Again, with Postgres, you might need to do this step yourself, but with ChromaDB, you get that out of the box. Now, I'm gonna go through one last thing where you see the response here and the score here. So I'm just gonna show you how the score looks like, and we're gonna go through our console to show that. So let's say, there you go. We're gonna look at our network tab and we're gonna search for something, okay? So let me maybe zoom in, okay. So we're gonna search for, let's say, I don't know, let's do it like last time. We're gonna do digital nomad credit card. And then I'm searching for it. You're seeing the responses here. So 1, 2, 3, 4, 5 blog posts. Now, if you quickly take a look at the call over here, you're gonna see, I'm gonna maybe blow this up a little bit. Yeah. So this is the response from our get recommendation or recommendation endpoint. And you're gonna see that for the 5 results you see in UI, I'm getting the score here. Okay, so this is how the score looks like, and you can set the score in a way where you have a cutoff. So let's say if it's less than or more than a certain number, you don't consider it relevant, hence you want to exclude it. You have that power too with ChromaDB. Okay, so I think we covered everything. The code is going to be linked in the description below. I am also going to attach the diagrams you see here. Hopefully that's helpful. If you have any questions, feel free to reach out to me either through email or in the comments below. And I will catch you folks in the next one. Take care. Bye-bye.